Hello everyone, and welcome to a discussion of one-dimensional projectile motion pre-activity. So we're going to start this unit out by doing a little activity on something called projectile motion. Now what is projectile motion? Well, we can define projectile motion as occurring for things that are projectiles. What's a projectile, you might ask? Well, that's any object upon which the only force is gravity. Okay, so only gravity is acting. You might remember we called that free fall in the past. That means air resistance and other things are either not there at all or so small that we can neglect them. Okay, so in this unit we're going to look at one and then two-dimensional projectile motion. We won't actually get to 3 dimensions until APC. So, how we're going to look at this motion, we're going to start out by looking at one-dimensional projectile motion. And so we've got a lab set up in the back where we have a soccer ball, and we have a little setup with a motion detector, that's this little deal down here, with some books on the side. And you're going to do 3 things. And along the way, you're going to try to predict what that motion will look like graphically. Position time graphs, velocity time graphs, acceleration time graphs. You're going to figure out what the acceleration actually is by taking the slope of the velocity time graph and answer some questions on it. And so this is kind of like our speeding up, slowing down activity or our moving right, moving left activity that we've done. So the first of 3 different things you're going to do is you're going to take the ball, hold it right over the motion detector, and drop it. See, the books are there to stop it before it hits the motion detector. Then you are going to take the ball and you're going to throw it up and catch it at its highest point. So you're not going to let it come back down. Again, you're going to take it, give it a little throw, and let it go up. And in this case, we're only looking at the part after it leaves your hands. Right? You got to get rid of the schmutz at the beginning and the end, as we did in the other 2 activities. So after it leaves your hand till they catch it. And then the last one, we're going to combine these together. You'll throw it up, and you'll let it come back down on its own. So again, you'll have it go up and come back down. A couple of things that will make this lab work a little better. Here is the program you're going to use. It's called One-Dimensional Projectile Motion. When you open it up, of course, you'll have to get it from the file that is on the website. But when you open it up, you will see that it is basically 3 graphs. A graph of position versus time, a graph of velocity versus time, and a graph of acceleration versus time. Now, one of the things that I did here is you'll notice I already put a linear fit box right here. See it? Linear fit box for the velocity time graph, because the slope of that will be the acceleration. And I've also locked down the axes here. So you'll notice you only have 2 seconds of time. So you've got to do this within 2 seconds. You only have 1.5 meters of position. And then the velocities correspond that you should be, and acceleration graphs are the right numbers so that you ought to be, or scale, sorry, so that you ought to be able to see what's going on. Alt minus deletes a trial, all that good stuff. Now, remember a couple things about the motion detector. It thinks of itself as 0 position. And when the ball is moving away from the motion detector, it means it's going in the positive direction. When it's moving towards the motion detector, it's going in the negative direction. Those 3 things are important to you trying to predict what the graphs will look like. As I just mentioned, because I've locked down the axes on the Data Studio file, you have to keep the ball within about 1.5 meters of the motion detector. If you go above that, you won't end up seeing it. All right, it'll go off the screen, and you can't hit the auto scale button because I've locked it down. Similarly, you have to do it within 2 seconds. This shouldn't be a problem if you're within 1.5 meters. You should have plenty of time. As soon as somebody hits start and you hear it clicking, do what you have to do, and then hit stop when it's done, and you should get the whole trial right on the screen. And then the last thing is, some of these are a little hard. You really have to work at being right above the motion detector. So you might have to practice a few times, okay, which is also a good thing so that you can kind of see the motion. If you don't get a good trial, if you throw the ball and it goes way off to the side or something like that, just delete it and do it over again, right? I mean, you have all hour to do this, so you don't need to, rush. All right? So if it takes you 5 times to try it before you get a good clean one, fine. Do it 5 times and take the 5th one and just get a good, clean result. Okay, so if you practice a little bit, you ought to get good at throwing the ball right above the motion detector. So this is the activity we will do tomorrow, and then we will start to learn about one-dimensional projectile motion.